Hi there. So what we have here is pan and tilt remote controlled camera, and the problem is that this motor is broken. So when I command this motor to rotate, it just vibrates but not moving far. So if we want to fix it, we need to understand how stepper motors work. So these low power steppers are made up from two parts. You can see there is a middle line here. So here's another part. This big one is made the same way, and I found another motor. I think it's from CD-ROM drive, and it's made the same way, one part and another. The big steppers like this are mechanically made in a different way, but they share all the same principles. Let's see this motor as an example. Here each part has only one winding, each having two contacts. So if we draw this, it will be, here is one winding and here's another one. So this goes to that part and this goes to that part. And there are four contacts, 1, 2, 3, 4. Probably these two are these and these two are these. So how it works? We can apply electricity to one of the windings and the motor rotates. And if we apply it in the opposite polarity, it's moves to another position. So by changing polarity on one winding, we can put the motor into two positions. So for example, it can rotate to this and this angle. And that's it. By one winding, we can move between two positions. And it will be jumping to and fro all the time. But when if we want it to actually rotate, that's why the second winding exists. So in order to rotate, after we applied a voltage here, next we apply it on the other winding, and if we do it in the correct polarity and sequence, the motor will rotate. And so the second winding will give us positions here and here, and as far as we get, for example, from here to here, the next position will be not this one but this one, and so on. So that's how steppers actually work. Okay, so this motor has two windings, each has two wires, 4 wires total, and this motor is called bipolar, so it means that we need to apply both polarities on each winding. And sometimes it's not convenient, because for this we need to have a driver that is able to change polarity. And so what engineers decided, they decided that they can add another winding. For example, let's put it here. Physically it's will be just in the same place. Inside, just two wires wind together in parallel. And for example, but basically, why do we change polarity? Because when we change polarity, the direction of magnetic force changes. And so we can have these windings. For example, this one is wind clockwise inside the motor, and this one is opposite. And so here we have both ends connected to the ground, and here we connect our voltage, just either plus here or plus here. Or it could be opposite, like the plus is common and we connect minus here. It doesn't really matter, but the thing is, that we can use only one polarity to move the motor. And right, so how the wires are arranged then? So now we have basically 4 windings in total, and there are some steppers that has all 8 wires coming out, and there are more steppers that have this connected. So with that we have just 6 wires, or these 2, because it's all the same, could be just connected together, and then we have 1, 2, 3, 4, 5 wires coming out of the motor. And so if we look closer to the motor in this camera, we can see that it has 6 wires. So it means that these wires are 1, 2, 3, the command point, and 4, 5, 6. First of all, we can see that 3 wires are coming into one side of the motor and another 3 into here. So it means that one of these 3 and one of these 3 is ground. And we can try to measure the resistance. So for example, we take these 3, and here we have 16, and here we also have 16, and between here we have 32. So it means that this wire is the middle, this is the end of one winding and the end of another winding. And here it's the same, middle one is connected to both windings, left one and right one. And if we measure the resistances here, so here we have 16, and here we have just 1, and 17 total. So it means that somewhere in the motor, between these 2 wires, there's a short circuit, and it prevents this motor from operating normally, because it's basically missing one step out of the mentioned 4. So how can we fix it? We can try searching for the same motor somewhere on eBay, or maybe of local market in your city, but it could be problematic to find exactly the same motor. It has quite specific long axle, and it could be produced many years ago. So we will try to rewind the winding just by ourselves. So first of all, what we need to do, we need to open the motor, and it's the halves are joined by these welding points. It's one on one side and the second on the other. Alright, so let's see what's inside. Okay, this part was healthy, and in here okay, so here is the rotor, and here we have the faulty winding. So now we need to remove all this tape here and the windings themselves. So unwinding finished, and now we need to determine the diameter of the wire. So we take a micrometer and it shows something like 0.14 millimeter. But the wire is coated with some paint, and so the actual diameter of the copper part could be something like 0.12 millimeter. So how can we calculate the necessary wire length? We just Google for wire resistance calculator. First link probably will do the job. And we have copper wire. We don't know the length for now, so we put 1 meter. Diameter 0.15, and we click calculate. So resistance of 1 meter such wire is 0.05 ohm, and we need to get 16 ohm. That was the resistance that we measured on the windings, so probably something like 17 meters will do the job. How far we can deviate from that? Usually in electronics we can go like 20% up or down, and it will keep working. Where can you get the wire? If you can't find it locally, you can try disassembling another stepper motor or some magnets, maybe some motors or relays. I tried, so I need 0.14 diameter wire, so I tried disassembling these relays, and so 6 volt relay, the wire was too thick, about 0.1 millimeter. 5 volt was about the same, and so I was able to find the wire in this electromagnet that I bought some time ago from eBay. Here is the same magnet disassembled, and this is the original wire. The diameter is the same, 0.14. We are making a double winding, so we need to rewind part of the wire to another spool. So now we have 2 wires. We just wind them together at one end. And we need to wind it here. So we are ready. Okay, so we have 2 windings, and we need to connect them so that the middle point will have one coil going to one direction and another into another direction. So we have to connect 2 opposite ends, for example, like maybe this one and this one. And we used to have 3 wires. Okay, the middle one was here. Okay, so the original one was 15.6, 15.5, and well, the problem is that okay, we get to 14. 1.5 ohm difference should be fine. The problem is that we only have one coil working. Okay, the problem obviously is that I connected the windings in the wrong way, so I had to take two opposite, and these two opposites should be one from one winding, another from another. So this should be like this. And what I obviously did is, it was one winding, it was another, and I connected two opposite from one winding, and here we have only one winding available. So I need to separate this and exchange it with one of these. Okay. Okay, so this one goes separate, and this one should be connected with this one. It's more convenient to use hot air gun here, but matches are more widespread and available tool. And I use matches, not lighter here, because lighter produce higher temperature, and all the wires will just start burning. And now let's see if we'll be able to close the motor. Okay, we have it closed. Now let's test it again. Okay, so the original side was, well, my multimeter is showing wonders. Okay, cool. How do we hold the motor together? Just by some copper sticky tape should be enough for it. Now I've connected the motor to the camera, and let's see how it works. And it's almost the same. And I think that the problem could be in the driver chip. So here on the PCB we have a driver. It's ULN2003 chip, and it's capable of driving 7 loads. It's basically 7 open collector transistors in one case. You can easily find the datasheet for this chip online. Okay, so to test if the driver is working, I will use an LED with a resistor, and we will connect it to all 4 coils with the motor connected, so the driver will work at its load. Okay, so here the brightest is quite high, and on the second output it's quite low. So it means, okay, the third one is high, and the fourth one is a bit lower, but also not bad. So probably the problem is with the driver. Hot air gun is coming to the rescue. Let's just hide other parts from heat. Okay, let's clean the pads. So everything is assembled back and the motor is working.